In this video, we will learn how to construct and interpret two-way frequency tables. It's about movie tickets. A movie theater is keeping track of the last 800 tickets it sold to two different movies. Of the 578 adult tickets sold, 136 of them were for the animated film and 442 were for the documentary film. This much data is for the adult tickets. Of the 222 student tickets sold, 181 of them were for the animated film and 41 were for the documentary film. Copy and complete a two-way frequency table as shown. Here they have given a frequency table, but it's incomplete. Let's complete it. Animated, adult. So you need to just see adult tickets. How many of them were for animated? It is 136, so this is the answer over here. How many were adult tickets for documentary? It was 442. The total below over here is the total adult tickets. 578, yes, it matches. What about the children ticket, the student ticket? So total were 222, so I can just write the total over here, 222. And how many were animated? In that, animated were 181, which is already given, and 41 were for the documentary. Maybe those students were forced by the adults to go to the documentary movie, I guess. So now over here, this right total is about adding it horizontally. 136 plus 181. So it'll be 7 here, 11, 1, 3. So it'll be 317. And what about this? It's going to be 483. So these are the totals horizontally, and vertically we write it over here. So the horizontal gives us the idea of the total animated movie tickets. Documentary totals are over here. And vertical totals give us the adult tickets and student tickets. And this final total is if you add the total number of tickets are given. This is the two-way frequency table. Now they have asked you to construct a relative frequency table. Now this is very, very simple. It's just that each of these slots must be divided by the total number of tickets. How many total tickets are there? It's 800. This at the right side corner, right side bottom, this number, the totals, is the final total of all the tickets. So you just have to divide each and every term by 800, and they want it in percent nearest 10th. So you have to just divide it by 800 and multiply it by 100 to get percent. This cancels. Just divide everything by 800, you will get the answer. Sorry, just divide everything by 8. So that would be the answer. You need to put in the calculator and solve. Over here, it will be 100%. That's the thing, because you divide by 800 and multiply by 100. So it'll be 100%. Now, please do it for all the values and make same table just like this, but you need to write it in percent. So over here, 181 divided by 8. 800 into 100 makes it 8. So I'm just dividing by 8. You need to write the answer over here in another table. So that would be the relative frequency table. The last question over here, question C. Find the probability that a ticket sold is an adult ticket given that it is a documentary ticket. So it's being sold to adults, but it must be condition it's a documentary. Given that it's a documentary ticket means the condition is given, it's a documentary ticket. Now here, don't just take this. Now let's see, what is this? This is a conditional probability, isn't it? They've asked you to work out the formula. So probability of what is the condition? Condition is documentary ticket, but we need to know it's an adult ticket, A. Condition, it's documentary. That means it will be probability of adult and documentary divided by probability of documentary only. What is the total documentary over here? Total is 483. Okay, now this would be wrong. I should not take 483. You should take the relative frequency. That means you need to find the percent. 483 divided by 800 into 100. This answer must be taken here. And over here, the and one, that is adult and documentary. It is 442 divided by 800 into 100. So we will use the calculator now. I've just typed in this equation over here. We are getting 60.375, but they have told nearest 10th. So I will write it as over here 60.4%. So the probability of the total documentary movies is 60.4%. 60.4. That percentage is fine. It's you just write it as 60.4. What about A and D? So now you need to just solve the next equation. Over here, just change it to 442, and here you go. The answer is 55.25%. So here it will be 55.25%. Now the probability, conditional probability would be this 55.3. I need to take it as 55.3, which I forgot over here as well, divided by 60.4. The answer is 90. You multiply this by 100, you will get the percent. That is 91.55%. 91.55%. Now again, they have told it's nearest 10, so let's just stick to the nearest 10. So it's just percent. This is 3. So the final answer over here is 91.6 percentage. Yeah, this is the frequency table, and here we have the relative frequency table. Um, okay, I just realized that this cannot be the answer. When you add this up, it's not 800, it's 483. I apologize for the error. It's 483. All the other values are all right. Yeah, all the others are correct. Only this one is the error. It's 483, not 84. So this is wrong. Other than that, everything is right. So and over here we got 91.6. Here we have a two-way frequency table which is already given. Compares data about students in a class who completed or did not complete homework, and those who passed or did not pass an exam. Okay, so this is the completed homework, did not complete homework, and among the students who completed homework, who passed and who did not pass. How many students completed their homework and passed the exam? Identify whether marginal or joint frequencies are used. Marginal and joint frequency in simple understanding is marginal is at the margins, the corner endmost ones, whereas joint is the inside one, the common ones. Okay, these four blocks are joint, whereas the totals are the marginal ones. Here, what is the question? How many students completed their homework and passed the exam? Completed homework, passed the exam. It's 18 number of students. That's the answer. And which did you use? It's joint frequency, the ones in the inside. The outside ones are marginal. Next question. Raquel surveys 160 people to determine if they prefer drama or comedy movies. The relative frequency table shows the data collected from the survey. Determine whether gender is independent of the movie type preference. Explain your reasoning. Here you need to first understand this is relative frequency table. It's already done. The probabilities are already given. You can find whether data is independent or not independent by finding the joint frequencies. That's the inner part. Now, if you multiply the marginals over here, the totals, and get this value, that is the expected answer, expected joint frequency, then that would mean it is basically independent. But if they don't match, if you find the expected and actual are different, then it's not independent. Let's take a calculator and see. All you need to do is to find this drama male, just multiply the totals. That is 37.5 percentages over here, or you can take it as 0.375 multiplied with 59.4%. Don't forget the percent. Now the answer is how much? It is 22.2%. It's not matching. So I can just stop. You can try the other values. All the values should match only if they match. Now, if you want this male comedy movies, you should take the total of male and multiply it with the total of this comedy movies. And then you will get, if you get 25%, that means expected and the actual ones are same. But here it's not same. You can see the expected joint, what we expect by multiplying is not matching. So therefore it is not independent. If at all they were all same, then it would be independent. For a business report on technology use, Darnell asks a random sample of 72 shoppers whether they own a smartphone and whether they own a tablet computer. His survey shows that out of 51 shoppers who own smartphones, 9 of them also own a tablet. While out of 21 shoppers who do not own smartphones, 15 of them do not own tablets either. Find the conditional probability that shopper has a tablet given that he or she has a smartphone. Justify your answer. This is a conditional probability. We have done similar problems already many times before. Here the condition is given, whatever is after given, that is, has a smartphone. So that must be the condition. What is the probability? Has a tablet given that has a smartphone. So whatever is down, must be down over here. Probability of having a smartphone. They have told over here, right? Total number of shoppers is 72. That is the total sample space divided by 72. And what is over here? How many shoppers have a smartphone? 51 owns smartphone. So 51 by 72. What is tablet and smartphone? You can see 9 of them also owns a tablet. So here 51 shoppers who own a smartphone also owns a tablet. So 9 basically. 9 out of 72. So basically cancel this out. 9 by 51 is the answer. If you do 9 by 51, you must get 17.7%. Let me just do it. Because we are taking the values in percent, I have multiplied by 100. Here it is 17.64 and they have rounded out to 17.7. If you're thinking why, because they have, say, rounded off these values. They have not taken the full values, but if you take the actual value, it should be 17.6 if you're rounding off to the nearest tenth. But they have not told the round off to anything, so it's fine. This is also the possible answer. This is the closest to it. But in the exam, it'll be much clearer, so not to worry. And it's better to take the actual values, the exact values. That is much accurate. Paz asks a random sample of seniors at a high school whether they own a car and whether they have a job. The results on the survey are shown in a two-way frequency table. Paz asks that the conditional probability that a student has a job, given that he or she has a car, is 46.7. Do you agree? So we need to just check this answer. So what is the condition probability that a student has a job given that he or she has a car? So job given car. Probability of job and car needs to be known, and probability of just car. Probability of car. So what is probability of job and car? Has a job and has a car. It is 21.9% divided by probability of car. That's over here, the total. 34.4%. Now let's just put it in the calculator. Here the answer we get is, okay, it should be 63.6%. So this is wrong. It's wrong over here. You can see 63.66, it's 63.7. You can see here 63.7%. You can see over here she has taken probability of C condition J. That means has a car condition, already has a job. So that is the mistake. We will just do this as well. If you just take probability of C condition J, that is probability of, this is the same thing, J and C itself, or C and J, it's the same thing, divided by, this is not C, probability of J. Sorry, it should be probability of J. So now the value, the first value is same, 21.9%, but over here, instead of taking this value, she has taken the job value, that is 46.9%. And then when you solve this, you must get 46.7%. You can see over here, when you solve this up, you're getting 46.7%. That is the mistake which Paz has done over here. That's the end of this topic, a simple topic. Just try to understand what exactly is a frequency table and relative frequency. And if you're thorough with conditional probability, which we studied in the previous question, this topic will be very easy as well.